Our lesson today is entitled Common Multiples. We have 3 learning targets. I can find the least common multiple of 2 whole numbers. I can explain what the least common multiple is, and I can explain what a common multiple is. So our first activity is a notice and wonder of multiples. So yesterday we talked about factors, right? And factors were are any number that can divide a larger number evenly, okay? So factors are how you break a number down, and then multiples are kind of the opposite of that. So multiples are the numbers that factors can make. So let's look. So identify all the multiples of 4 in this list. So 4 is obviously a multiple of 4, right? 4 times 1 is 4. 4 times 2 is 8. So 8 is a multiple of 4. 4 times 3 is 12. So that is a multiple of 4. So I'm just going to put my list down. 4, 8, 12, 16, 20, 24. And those are the only ones from that list, because that list stops at 26. So here is our list of multiples for 4. And now we have to do the multiples of 6. So once again, multiples are when you multiply that number, what you get. So 6 times 1 is 6. So 6 is a multiple of 6. 12 is a multiple of 6. 18 is a multiple of 6. So 6, 12, 18, and 24 are all multiples of 6. So if 6 multiplies by a certain number, these are all possibilities of the numbers that you will get. So at this point, if you want to go ahead and fill out your notice and wonder chart, you can pause the video and do that now. Here are some notices and wonders that I thought of. 4 and 6 have common multiples of 12 and 24, meaning that I can multiply 4 by something to get 12, and I can also multiply 6 by something to get 12. They both also have numbers that are multiples that are not in common with each other, right? 16 is a multiple of 4, because 4 times 4 is 16, but I can't multiply 6 by anything to get 16. So, what other multiples would there be if we kept counting? We'll see that later. And why are all the common multiples of 4 and 6 also multiples of 12, right? Because if we look here, we can get 4 times 3 gets us 12, and 6 times 2 gets us 12. And then we can also see that I can get 24 is a multiple of 4, and 24 is also a multiple of 6. And 24 is also a multiple of 12, right? 12 times 2 is 24. So these are some of the things that we're going to be investigating. So our next activity is called the florist's order. So a florist can order roses in bunches of 12 and lilies in bunches of 8. Last month she ordered the same number of roses and lilies. If she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? Find all of the possible combinations. So I have kind of constructed this table for you to help organize your work on finding the different combinations that she could have had. So once again, we can see clearly if we ordered one bunch of each, one bunch would give us 12 roses and 8 lilies. So this is kind of like a ratio table. So if I got 2 bunches, then that would be 24 roses, and that would be 16 lilies. So why don't you pause this video and go ahead and fill it all out yourself. Just to jump down, so 36, 48, 60, 72, 84, and 96. And I've got to stop there for the roses because it said that she ordered no more than 100 of each kind of flower. Here, 8 times 3 is 24, 32, 40, 48, 56, 64, and 72. Oops. Alright. Now I'm just going to keep this a little bit neater. So it says that she ordered the same amount of each flower. So I could see that here she could have ordered the same amount of each flower, because I'm seeing 24 twice, right? So one possibility is that she ordered 2 bunches of roses, which is 24, and 3 bunches of lilies, which is 24. So that meets the requirement because she got the same amount of flowers by ordering these different bunches. So what other numbers do we see that are common with one another? I can see here we got 48, and 48 also works here as well. So then she could have also ordered 4 bunches of roses, and that was 6 bunches of lilies, and that would give her 48 of each type of flower. So that works. Any other numbers that you see in common? I see one more. 72 would also work. Right, so if she ordered, I can see here that that would be 6 bunches of roses. Gives her 72, and that would be 9 bunches of lilies. Would also give her 72. So these are the 3 different possibilities for her order. So what is the smallest number of bunches of roses that she could have ordered? What about the smallest bunches of lilies? Well, the first place where they meet is here at 24. So 2 bunches of roses and 3 bunches of lilies is the smallest number that she could have ordered, because that is the first time the number of flowers was equal in each category. 24 flowers. Right, because if she ordered the same, if she wanted the same amount of flowers for each, that is 24 is the first time that the numbers are equal. So she would have had to have done 2 bunches of roses and 3 bunches of lilies. Now, the least common multiple of 6 and 8 is 24. What do you think the term least common multiple means? So once again, let's find the different multiples of 6. 6 times 1 is 6. 6 times 2 is 12, 18, and 24. And then let's talk about 8, 16, 24. 8 times 1, 8 times 2, 8 times 3. And it says the least common multiple is 24. So why don't you try and write your best definition? So, the least common multiple is the smallest number that 2 numbers can both multiply to. Alright, so 6 can multiply by 4 to get to 24, and 8 can multiply by 3 to get to 24. So that is the first time those 2 numbers meet. Okay, so that is the smallest number that both 6 and 8 can multiply to. So now, find all of the multiples of 10 and 8 that are less than 100, and find the least common multiple of 10 and 8. $10, 20, 30, 40, 50, 60, 70, 80, 90. Because they all need to be less than 100. And 8 be 8, 16, 24, 32. Remember, multiplying is essentially like skip counting. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. And I'm going to stop right there because I see 80 is the first number that 8 can multiply to and 10 can multiply to. That is the first number that both of those can multiply to get me to. So 80 is the least common multiple of 8 and 10. So it's the first multiple that both numbers can get to. We could also say, or that both numbers are a factor of, right? So 10 and 8 are both factors of 80, because 80 can be divided by 10 and 80 can be divided by 8. So why don't you do number 3 independently, find all the multiples of 7 and 9. Aha! 63 is the least common multiple here. Awesome. So, are you ready for more? So, I'm going to pause the video real quick and answer these so we can just kind of brush over this. Alright, so we are finding the least common multiple of 10 and 20. So once again, we're going to make a list of all the multiples. 10, 20, 40. But wait a second. I already found it. Because 10 times 2 is 20 and 20 times 1 is 20. So 20 is the least common multiple. That is the first number that they are both multiples of. Alright, and let's try number 2 then. So we have 4 and 24. 4, 8, 12, 16, 20, 24. And I'm not even going to go anywhere with the multiples of 24 because they're already meeting right there. So the LCM is 24. So in the previous two questions, one number is a multiple of the other, right? So 24 is a multiple of 4. Because 4 times 6 is 24, and 20 is a multiple of 10, because 10 times 2 is 20. So what do you notice about the least common multiple? Do you think this will always happen when one number is a multiple of the other? Explain your reasoning. And so, that is true. So, when one number is a multiple of the other, the larger number will always be the LCM. Okay, so I knew that 20 was a multiple of 10, so 20 is the first place that these two numbers will meet. And 24 is a multiple of 4, so 24 is the least common multiple because that's the first number where they meet. Like, why even keep going to 48 or whatever, because I can already see right here that they line up.